Hello students, good morning. So we are in the session 9 of work, energy and power topic. In Canada, we'll continue our discussion. Already in session 8 we have started with the discussion about the spring related applications. In we will try to complete the applications of the work energy theorem based on the spring related questions. Okay va? So paranga, what is it that we are beginning with? Finding the maximum compression in a spring with a rough surface. So we are looking at the horizontal surface. Horizontal surface, but surface rough. Rough means friction varum. Okay va? Paranga. So இப்படி ஒரு block of mass m moving with a velocity v0. One that it is colliding with the spring oda constant எவ்வளவு k. Okay va? இங்க என்னன்னா the surface is rough. So mu1 வெச்சுக்கோங்க. What is mu? The coefficient of friction. Okay va? So if we have to find out what is the maximum compression in the spring. So என்ன ஆகும் பாருங்க, like இதுக்கு முன்னாடி கிளாஸ்ல நம்ம ஒரு சேம் as it is ஒரு கான்செப்ட் நம்ம டிஸ்கஸ் பண்ணிருக்கோம். அங்க என்ன தெரியுமா, ஒரே ஒரு டிஃபரன்ஸ் என்னன்னா அங்க ஃபிரிக்ஷன் கிடையாது, இங்க ஃபிரிக்ஷன் வருது அவ்வளவுதான். So here addition to the block coming and colliding with the spring and compressing it, just ஒரே ஒரு எக்ஸ்ட்ரா பாயிண்ட் என்னது, we are having friction between the block and the surface அவ்வளவுதான். ஓகேவா? So இப்போ பாருங்க, when the block is hitting that spring, அது ஒன்று state 1 ன்னு சொல்லலாம். இங்க பாருங்க maximum compression, இது என்னது, the maximum compression, that is the state 2. இப்போ என்ன தெரியுமா, what is the initial kinetic energy of the block? Half m v0 square. Final kinetic energy எவ்வளோ, நம்ம maximum compression சொன்னா what is it? The block is compressing the spring such that it is not able to move any further. அப்படிதானா? So it is not able to move any further ன்னு சொன்னா அதோட velocity will become what? 0 தானா? So kinetic energy in the final state எவ்வளோ, maximum compression stageல 0. அந்த மாதிரி spring potential energy பாருங்க, initially spring எப்படி வரும், natural stateல தானா? So the potential energy will be 0. Final state la half k into x square. The x value தான் நமக்கு வேணும், that is the maximum compression. ஓகேவா? அடுத்தது என்ன, gravitational potential energy கான்செப்ட் இங்க வராது. ஏன்னா because the mass is moving just on the அந்த ஒரே horizontal surface மேல தான் மூவ் ஆயிட்டு இருக்கா. ஓகே, so அதனால that is we take as a reference line. So potential energy initial point lo 0 da, final point also it will be 0. Okay va? So gravitational potential energy concept inga varadu. Ipo parunga, work done by normal reaction evlo 0. And the block is moving along the contact plane, normal reaction is perpendicular, adanal work done by normal reaction is what? 0. But then here we will have work done by friction work. Here what we will have work done by friction. Adu eppadi calculate pandrathu parunga. How do we calculate work done by friction? அதுக்கு என்னன்னா, let us take the mass. பாருங்க, vertically அதோட weight act ஆகும். அந்த மாதிரி normal reaction, vertically motion கிடையாது, which means normal reaction ஓட value எவ்வளோ, mg. The block is moving to the right side, so friction acting on the block, அது எப்படி act ஆகும், opposite direction தானா? Block right side move panna, the friction acting on it will be what? Opposite direction, which means the left side act out. So that value enna, because we are looking at what? Friction when there is a relative motion, that is what? Kinetic friction. So kinetic friction is what? Coefficient of friction into normal reaction. So which is what? Mu into normal reaction, that is what? Mu into mg is the kinetic friction of the value. Paranga, work done by friction will be what? Frictional force into what is the displacement of the block? X. அதுக்கப்புறம் what is the angle between them? பாருங்க, what is the angle between them? Displacement எப்படி? right side, frictional force left side, so angle between them எவ்வளவு? 180 தானா? so cos 180 வரும். so what is it? cos 180 எவ்வளவு? -1, so minus mu mgx. இதுதான் work done by frictional force. so இங்க என்ன, like we will not have conservation of mechanical energy, and the concept inga varadu. Because here we are having work done by the non-conservative force. okay, paranga ipo namakku enna varum result? work done by the actual statement of the work energy theorem enna? work done by the non-conservative forces and other external forces. idana irukka non-conservative force minus mu mgx is equal to change in kinetic energy, means final value minus initial value, plus change in potential energy. potential energy la inga enna varum? verum and spring potential energy mattum da. change in potential energy will be what? final value minus initial value. so paranga, what is the equation we are getting finally? minus mu mgx is equal to half kx square minus half m v naught square. okay va, enna varudhu? minus mu mgx is equal to what? half kx square minus half m v naught square. idhula enna, we have taken not the values, நம்ம ஒரு particular values நம்ம எடுக்கல, we have taken with the parameters. அதனால என்ன, we are getting a equation in terms of the parameters. the parameter formula தான் வருது பாருங்க. we are having the equation in terms of what? mu m k v naught. அந்த ஒரு representation தான் we are getting the expression. இங்க பாருங்க, what is this one? this is the என்னது? it's a quadratic equation. என்னது? this is the what? quadratic equation in x. actual values இருந்தா then we will be able to solve it. say for example mu is equal to 0.1, m is equal to 5, அப்படி நம்ம கிட்ட values இருந்தா வெச்சுக்கோங்க, then we will get a quadratic equation like maybe 5x square plus 2x minus 10 is equal to 0. அந்த மாதிரி நம்ம கிட்ட ஒரு quadratic equation வரும். அது solve பண்ணா we will get what is the values of x. okay, so இங்க என்னன்னா we will just leave it here. so இப்படி நம்ம கிட்ட ஒரு quadratic equation வரும் whenever we are having a block compressing a spring on that horizontal surface with friction. அப்ப நம்ம கிட்ட என்ன வரும்? we will get a quadratic equation. solve பண்ணா அதுல இருந்து we will get two values of x. எத்தனை values வரும்? because quadratic equation will have two roots, right? in that usually என்ன தெரியுமா? one of them will be positive, other will be negative. so we will go with the positive. and x is the distance moved by the block to the right side, right? so that has to be what? positive. so in the quadratic equation solve panna enna theriyuma, usually you will get what? two roots, in that one will be positive, other will be negative. so we will accept the positive one. we will take the positive one as the maximum compression. okay va, so negative value we will have to omit. so this is the basic approach. and then we have not taken the actual values in a medical, we have solved this with a parameter approach. parameter approach and sonna, what is it? we are just taking general numbers like m mu apadi. okay so idhula irundhu we will be able to get what? in the quadratic equation irundhu we will be able to get the value of x. okay, so this model of question enna, we will have little bit more konjam complexity irukum. it is not the friction illenna we have seen it will be straightforward. friction illenna we have got the answer very straightforward. but if there is a friction means we will get a quadratic. inga mattum kadiyadu, we will see in other problems also enga friction varudho those cases, right? when you are having the spring problems anga enna theriyuma, we will get quadratic equations. okay, so the quadratic equation solve பண்ணிட்டு அதுல இருந்து we have to find out the answer. okay va, so this is about the maximum compression in the spring on a horizontal surface with roughness. okay va, so அடுத்து பாருங்க, spring on an inclined surface. so இதுக்கு முன்னாடி நம்ம பார்த்தது என்ன? spring is on the horizontal surface, but we can have problems where the spring can be on the inclined surface. So difference என்ன வரும் தெரியுமா? ஒன்னும் வராது. ஏன்னா because for spring there is no kinetic energy, there is no gravitational potential energy. வெறும் spring will have what? Only spring potential energy. Okay va? ஏன்னா because our assumption is what? Spring is what? Massless தானா? So அதனால spring அதுக்கு ஒரு kinetic energy concept இருக்காது. அந்த மாதிரி there will be no concept of the gravitational potential energy also for the spring. Okay va? வெறும் இந்த spring potential energy மட்டும் இருக்கும். When you are keeping the spring on the inclined surface, இதுல என்ன usual என்ன தெரியுமா? We will have the object compressing or expanding the spring along the inclined plane. In the direction la varum. The spring will be compressed or elongated along the inclined plane. So appo அந்த value தான் நம்ம பார்க்கணும். So spring compression or elongation னு சொன்னா what you have to take? You have to take the distance that is there. இங்க பாருங்க, like say along the plane நம்ம ஒரு distance d drag பண்ணா what is the expansion of the spring going to be? d da. Okay, so we have to measure the distances along the inclined plane. What is the difference? So remember, the extension or compression, the extension or compression in the spring will be determined எது பேஸ் பண்ணி? By the distance moved by the object along the plane. So நம்ம என்ன பார்க்கணும்? We have to look at what is the distance. இப்போ நம்ம அத ஸ்ப்ரிங் கூட நம்ம ஒரு block attach பண்ணி வெச்சுக்கோங்க. We have to look at what is the distance moved by the block along the inclined plane. Okay, அதுல இருந்தா we will know what is the elongation of the spring or compression in the spring. Okay, all of the difference. அது தவிர there will be no much difference. இங்க என்ன, we look at one question. இந்த sample question பாருங்க. A system of wedge and block is shown. Wedge and சொன்னா என்னது? This is the wedge. So inclined plane and சொல்றதுக்கு பதிலா what we can say? We can also say wedge. Okay வா? A system of wedge and block. இங்க பாருங்க, this is the block. Is released with the spring in the natural length. So spring initially எப்படி இருக்கா? Natural length. Natural length இருந்தா அதோட potential energy எவ்வளவு? 0 தானா? So இது நம்மளோட state 1. Release பண்ணா என்ன ஆகும்? There will be a component of the weight acting on the block along the plane. So அப்படியே அது move ஆகும் along the plane downwards. Okay, பாருங்க, all the surface are frictionless. So இங்க friction concept கிடையாது. Okay, find maximum elongation in the spring. என்ன நம்ம find out பண்ணணும்? We should find out what is the maximum elongation in the spring. பாருங்க, so அப்படியே அது மூவ் ஆயிட்டு let us say இங்க வருதுன்னு வெச்சுக்கோங்க, by moving a distance x. So distance x is along the plane. Okay வா? So அந்த x தான் நம்ம calculate பண்ணணும். So இப்ப பாருங்க, initially right block oda kinetic energy எவ்வளவு? ஏன்னா we are releasing from rest. Releasing from rest தானா? Because when you are releasing it, அதோட kinetic energy எவ்வளவு? It will be 0. Finally, when we are saying maximum elongation ன்னு சொன்னா ஒரே ஒரு செகண்ட். ஓகே, ஸோ இப்போ பாருங்க மேக்ஸிமம். ஸோ KE1 எவ்வளோ? அந்த இனிஷியல் பாயிண்ட்ல கைனடிக் எனர்ஜி எவ்வளோ? 0. மேக்ஸிமம் எலாங்கேஷன் சொன்னால் இங்கே பாயிண்ட் 2 வந்ததுக்கப்புறம் இட் will again be coming to rest. ஸோ கைனடிக் எனர்ஜி 2 எவ்வளோ? 0. ஸோ நடுவில் the block is moving with some velocity, பட் இனிஷியல் பாயிண்ட்ல கைனடிக் எனர்ஜி எவ்வளோ? 0. அந்த மாதிரி ஃபைனல் பாயிண்ட்ல கைனடிக் எனர்ஜி 0. ஓகேவா? அடுத்தது என்ன? ஸ்ப்ரிங்கோட பொட்டன்ஷியல் எனர்ஜி இனிஷியலி எவ்வளோ? 0, பிகாஸ் நேச்சுரல் லென்த்ல இருக்க ஸ்ப்ரிங். ஃபைனல் half kx square. other final spring potential energy. Here there will be also the gravitational potential energy of the block. அது எப்படி வரும் பாருங்க. The block is moving on the inclined plane, means there is a vertical motion for the block. The horizontal surface மேல மூவ் பண்ண மாதிரி கிடையாது. The block is moving on an inclined plane, means it will have a vertical displacement. பாருங்க, இங்க ஒரு நம்ம ரைட் ஆங்கிள் ட்ரையாங்கிள் மாதிரி டிசைன் பண்ணலாம். அதோட ஹைபோட்டெனஸ் எவ்வளவு x? So the vertical displacement h, right? So what is the relation? இது என்னது theta. Using the properties of similar triangles, right? Inclined plane angle theta means இங்க வர angle also will be what? Theta. பாருங்க, இந்த small right angle triangle sin theta is equal to h by x, means h ஓட வேல்யூ என்ன? x sin theta. h ஓட வேல்யூ எவ்வளவு? x sin theta. இப்போ என்ன தெரியுமா, கிராவிடேஷனல் பொட்டன்ஷியல் எனர்ஜின்னு சொன்னா we have to always have a reference. நமக்கு என்ன வேணும்? ரெஃபரன்ஸ் வேணும். So usually இப்போ ஒரு ஆப்ஜெக்ட்டோட மோஷன் இருந்தா வெச்சுக்கோங்க, usually என்னது, we will take the bottommost point of that motion as the reference line. அப்படிதானா? இங்க பாருங்க, point 1 இருக்கா, point 2 இருக்கா. We will take the point 2 as the reference line. அது நம்ம ரெஃபரன்ஸ் லைனா எடுக்க போறோம். point 2 நீங்க ரெஃபரன்ஸ் லைனா எடுத்தா, what is the gravitational potential energy of the block at the point 2, 0? ஏன்னா அதுதான் நம்ம ரெஃபரன்ஸ் எடுக்கிறோம். ஓகே, அப்போ gravitational potential at point 1 எவ்வளவு? m into g into h. h means what? m into g into x sin theta. இதுதான் gravitational potential energy of the block at the point 1. இது எப்படி வருது? by using point 2 as the reference line. So point 2 கிட்ட நம்ம gravitational potential energy 0 எடுக்கிறோம், because that is what we are choosing as the reference line. ஏன்னா gravitational potential energy, right, always depends upon what is our reference line. Okay, so இப்போ என்ன பாருங்க, initial kinetic energy இருக்கா, final kinetic energy இருக்கா. Initial potential energy for the spring is there, final expression நம்ம கிட்ட இருக்கா. அந்த மாதிரி gravitational initial value also is there, final value also is there. Friction கிடையாது. Other than friction, there will be only normal reaction acting on the block. The block மேல என்ன இருக்கும்? normal reaction இருக்கும், but block is moving along the contact plane. So work done by normal reaction அது எவ்வளவு வரும்? 0 தானா? Whenever an object is moving along the contact surface, work done by normal reaction எவ்வளவு? 0. So இப்போ பாருங்க, if the work done by the non-conservative forces and other external forces is 0, which means what? We will come to our usual principle. என்னது? conservation of mechanical energy தானா? So conservation of mechanical energy சொன்னா இங்க பாருங்க, we will get kinetic energy but at 0. ரெண்டு இடத்துல 0 தான், initially 0, finally also 0. potential energy ரெண்டு terms வரும். ஏன்னா spring ஓட potential energy ஒன்னு, ரெண்டாவது the gravitational potential energy of the block. இப்போ பாருங்க, kinetic energy 0, initially spring potential energy எவ்வளவு? 0. வெறும் we will have a gravitational potential energy of the block. அது எவ்வளவு? mg into x sin theta, that is equal to final kinetic energy எவ்வளவு? 0. Finally spring will have a potential energy, அதோட வேல்யூ என்ன? half kx square. Final gravitational potential energy எவ்வளவு? 0. இப்போ பாருங்க, இதுதான் relation. What is the relation? mg x sin theta is equal to what? half kx square. இப்போ நமக்கு என்ன வேணும்? We are looking for the value of x தானா, because they are asking us what? Find the maximum elongation in the spring. Spring குள்ள whatever is the maximum elongation that will happen. சொல்லுங்க, what will be the maximum elongation in the spring? அப்படி நீங்க ஒரு x ஓட வேல்யூ கேன்சல் பண்ண வெச்சுக்கோங்க, என்ன இருக்கும்? mg sin theta is equal to half kx. So 2 அந்த பக்கம் போனா it will go to the numerator, k will go to the denominator. So பாருங்க, 2mg sin theta by k, அதுதான் x ஓட வேல்யூ. எங்க இருக்கு ஆப்ஷன்? 2mg sin theta by k. So then this is the maximum elongation in the spring. Okay va? இது இன்னொரு மாடல் ஆஃப் கொஸ்டின். ஏன்னா ஸ்ப்ரிங் மே நாட் பி ஆன் த இன்க்ளைன் பிளேன் பட் the connected object, right? இங்க பாருங்க, so there is a 2 kg block that is initially related to the spring. Overall motion என்னன்னா the 2 kg block might be traveling on the inclined plane. அப்படி இருக்கலாம். இது ஒரு different model of question. ஏன்னா இங்க பாருங்க spring inclined plane மேல இல்ல. spring எப்படி இருக்கா? spring is on the horizontal surface only, but the block that is connected to the spring is going on to the inclined plane. இது ஒரு different model type of question. பாருங்க, in the figure shown all the surfaces are smooth, means friction கிடையாது. The force constant எவ்வளவு? 10 Newton per meter. So force constant எவ்வளவு? 10 Newton per meter. ஓகேவா? So Newton per meter. Block of mass 2 kg is not attached to the spring. It is not attached and சொன்னா connected. It's not attached. ஓகேவா? The spring is compressed by 2 meters and then released. அந்த ரெண்டுத்துக்கு நடுவுல there is no physical connection. அப்படியே நம்ம 2 kg block வச்சிட்டு we are just compressing by how much? 2 meter. ஓகேவா? so இத நம்மளோட position 1 நினைக்கிறா. that is the compressed state of the spring. ஓகேவா? we are releasing it. releasing னு சொன்னா block ஓட kinetic energy எவ்வளவு? 0. find the maximum distance d traveled by the block over the inclined plane. so இப்ப பாருங்க, அப்படி அந்த block வச்சிட்டு we have compressed the spring. release பண்ணா என்ன ஆகும்? spring அப்படியே will try to push the block, so the block will start moving. It will move away from the spring, and because it will get kinetic energy, right, அதனால it will start going on the inclined plane. but என்ன தெரியுமா? inclined plane ஓட when it is climbing up the inclined plane, right, என்ன ஆகும்? the gravitational potential energy of the block will be increasing. அப்படிதானா? ஏன்னா because it is getting elevated, the kinetic energy will keep decreasing. அதோட gravitational potential energy will increase and kinetic energy will decrease. ஒரு இடத்துல என்ன? the kinetic energy will finally become 0. that distance தான் அதுதான் நமக்கு வேணும். the distance traveled by the block along the inclined plane. maximum distance சொன்னா what is it? block will again come to rest. பாருங்க, this is point 2 வெச்சுக்கோங்க. that point 2 represents what? the maximum distance traveled by the block on the inclined plane. so அப்ப என்ன? initial kinetic energy of the block எவ்வளவு? 0. ஏன்னா we are the block வச்சிட்டு we are compressing the spring. அப்படி compress பண்ணி we are releasing. ஓகேவா? so initial kinetic energy எவ்வளவு? 0. அது மாதிரி final kinetic energy, block is moving always along the contact surface, either on the horizontal floor மேல ஆகட்டும் or on the inclined plane, always moving along the contact surface. so work done by normal reaction எவ்வளவு? 0. initial state ல we will take this as the reference line வெச்சுக்கோங்க, that horizontal line. ஓகேவா? gravitational potential energy of the block எவ்வளவு? 0. இங்க பாருங்க, final state is at a height h above the reference line. how do we relate the h to the d value? பாருங்க, sin 30 is equal to h by d தானா? sin 30 எவ்வளவு? half, means h is equal to d by 2. அது relation. so the final gravitational potential energy of the block எவ்வளவு? m, mass is 2, g எவ்வளவு? 10, mg into h. அதுதானா? so 2 into 10 into h எவ்வளவு? d by 2. so that is the 10d. that is the final gravitational potential energy of the block. அப்புறம் we look at what is the initial spring potential energy. ஏன்னா initially we are compressing the spring, so எவ்வளவு? 2 meters compression, which means half into k எவ்வளவு பாருங்க? 10 into compression எவ்வளவு? 2 meters தானா? so 2 square வரும். so which is what? ஒரு 2 cancel ஆயிடும். so it will be what? 20 joules. that is the initial spring potential energy. finally and a spring relax ஆயிடும். so finally எவ்வளவு? 0. finally spring will not have any potential energy. அவ்வளவுதானா? so this is the concept. இப்போ என்ன? friction கிடையாது. what is the normal reaction? 0. which means what? we will go back to our usual principle. என்னது? conservation of mechanical energy. apply பண்ண என்ன வரும் பாருங்க? initially kinetic energy plus total potential energies means initial kinetic energy 0, gravitational potential energy 0, spring potential energy மட்டும் இருக்கும், that is 20 joules is equal to final kinetic energy 0, final gravitational potential energy 10d plus final spring potential energy 0, அவ்வளவுதான். So 20 is equal to 10d. இதுல இருந்து d ஓட வேல்யூ என்ன வரும்? 2 meters. 20 by 10 தானா? ஏன்னா everything we have taken in the SI system of units. So பாருங்க, the block will be moving on that inclined plane. What is that? பாருங்க clear ஆகுங்களா? என்ன கேக்குறாங்க? The maximum distance d traveled by the block over the inclined plane means நம்ம என்ன மெஷர் பண்ணணும்? We have to measure the distance traveled along the inclined plane. Okay va? So we have to be careful while reading the questions. Question statement நம்ம படிக்கும்போது we have to be little bit careful what they are asking us. Okay va? So what is the answer for this? D எவ்வளவு? 2 meter. That is the distance traveled by the block on the inclined plane, the maximum distance. Okay va? So இந்த மாதிரி ஒரு question வரலாம். Like here what is it? It's not like the spring is on the inclined plane, but we are having the spring related to a block and the block is moving on the inclined plane. Okay. Other than now we can have spring on the inclined plane attached to a block, like as it is in the problem நம்ம solve பண்ணிருக்கோம் இதுக்கு முன்னாடி. We got what is the maximum elongation in the spring. Just now only we solved it, right? இங்க என்னன்னா we are bringing in the friction concept, அவ்வளவுதான். இங்க எக்ஸ்ட்ரா என்ன வருது? Friction is coming. இது எப்படி நம்ம சால்வ் பண்றது பாருங்க. How do we solve this one? So இது initial state 1 வெச்சுக்கோங்க. அடுத்தது state 2, the maximum elongation. மத்ததெல்லாம் everything as it is. Already நாம இதுக்கு முன்னாடியே பார்த்திருக்கோம். What is it? Kinetic energy 1 is 0. அந்த மாதிரி kinetic energy 2 எவ்வளவு? 0. Because initially the block is released. அதுக்கப்புறம் finally also it is coming to rest. அதனால kinetic energy 0 initially, அந்த மாதிரி finally also 0. ஓகேவா? Initial spring potential energy எவ்வளவு? 0. Because spring will be in the natural state. Final spring potential energy எவ்வளவு? half kx square. Gravitation பத்தி நம்ம already derive பண்ணிருக்கோம். This is theta means height. H will be equal to what? X sin theta. Already நம்ம இதுக்கு முன்னாடி பார்த்திருக்கோம் as it is. Okay. இங்க ஒரே டிஃபரன்ஸ் என்னன்னா we are going to talk about the friction coming into picture. ஓகேவா? So இப்போ நம்ம point 2 நம்ம ரெஃபரன்ஸ் எடுத்தா gravitational potential energy காக what is the PE2 gravitation 0, PE1 gravitation எவ்வளவு? mgh which is equal to mg into x sin theta. So இப்போ நம்ம எதுக்காக நம்ம சால்வ் பண்ணிட்டு இருக்கோம் இந்த ப்ராப்ளம்? for the value of x, that is the maximum elongation in the spring. ஓகேவா? So இப்போ பாருங்க, when the block is coming along the plane downwards, there will be a friction. எப்படி ஆக்ட் ஆகும்? How the friction will be acting? Opposite direction தானா? How the friction is going to act? Opposite direction. இங்க பாருங்க, the block இப்படி வருது, coming along the plane downwards. So friction எப்படி ஆக்ட் ஆகும்? Opposite direction. Kinetic friction. Kinetic friction ன்னு சொன்னா what is the value of the kinetic friction? Kinetic friction ஓட வேல்யூ என்ன? mu into normal reaction. Normal reaction on that inclined plane, when you take the component of the weight, எப்படி வரும்? One component will be perpendicular to the plane. அதோட வேல்யூ என்ன? mg cos theta. இது ஆல்ரெடி நம்ம நிறைய பார்த்திருக்கோம் in the Newton's laws of motion. When you take the weight component, right, ஒரு component will be parallel to the inclined plane. அதோட வேல்யூ என்ன? mg sin theta. இங்க ஒரு component will be perpendicular to the inclined plane. அது என்னது? mg cos theta. இப்போ பாருங்க, block is moving along the plane. அப்போ perpendicular to the plane motion கிடையாது. Which means what? Normal reaction ஓட value will be mg cos theta. So அதுல இருந்து we'll get the value of frictional force. என்னது? mu into mg cos theta. இதுதான் frictional force ஓட value. இப்போ பாருங்க, the block is moving along the plane downwards. எப்படி மூவ் ஆயிட்டு இருக்கா? The block is moving along the plane downwards. But friction is acting along the plane upwards. So அந்த ரெண்டுக்கு நடுவுல what is the angle? What is the angle between them? So displacement of the block எப்படி இருக்கா along the plane downwards x, frictional force is along the plane upwards. So what is the angle between them? 180. இப்போ பாருங்க work done by the friction, what is it? Force value into displacement to the value into cos of angle between them. Adhanadi cos 180. Cos 180 means -1. So minus mu mg cos theta into x. That is the work done by the frictional force. So negative varum. Enna because frictional force is acting in opposite direction to the displacement of the block. Block அப்படியே coming down the inclined plane, but frictional force is acting upwards the plane. அதனால work done by friction will be what? Negative. Okay va? So இப்ப பாருங்க இங்க என்ன தெரியுமா, we will not have conservation of mechanical energy. அது வராது. Because here we have a work done by non-conservative force. So we will have to go to the original statement of the work energy theorem. என்னது? Work done by the non-conservative forces and other external forces. பாருங்க, what is it? Mu mg cos theta into x. இங்க என்ன தெரியுமா, we are not going to get the exact answer. ஏன்னா we are solving the question with parameters. இங்க நம்ம exact values எடுத்து solve பண்றது கிடையாது. We are just taking the parameters so that in future, right, when you are getting a question with the numbers, அப்ப என்ன ஆகும், இங்க mu க்கு பதிலா you will have some 0.1 or 0.2. in place of m you will have the value that they will give. அதெல்லாம் substitute பண்ணா we will get the exact answer. ஓகேவா? so இங்க பாருங்க, work done by the non-conservative forces and other external forces is equal to what? Change in kinetic energy, initially 0, finally 0, over plus change in potential energy. Change in potential energy ன்னு சொன்னா we will have what? Two potential energy terms வரும். Change in the spring potential energy எவ்வளவு பாருங்க, finally half kx square, initially எவ்வளவு 0. Change in gravitational potential energy எவ்வளவு, finally 0, initially என்னது mg x sin theta. அதுதான் initial potential energy at 0.1. ஏன்னா எது நம்ம ரெஃபரன்ஸா கன்சிடர் பண்றோம், we are considering the point as the reference line. அங்கிருந்து 0.1 is at a vertical height of what? X sin theta. ஓகேவா? so பாருங்க என்ன வருதுன்னு, minus mu mg cos theta into x is equal to what? Half kx square minus mgx into sin theta. பாருங்க, what is it? என்னது? quadratic தானா? solve பண்ணா we will get the value of x. ஓகேவா? so இப்படிதான் இருக்கும் approach. The problem where we are having the friction. ஓகேவா? so in case they are giving us the exact numbers means and the numbers அப்படியே நம்ம substitute பண்ணி we can get the answer. so வேணும்னா we can even just get the answer from here. பாருங்க, இப்போ நம்ம x terms ரெண்டு ஒரே சைடுல எடுத்துட்டு வந்தா the x will get cancelled. அதுலேருந்து we can get the expression also, but we can leave it here itself. so என்ன பண்ணலாம், if you want to know the value of x means அப்படியே நீங்க x cancel பண்ணலாம், ஒரு x value நம்ம cancel பண்ணலாம். cancel பண்ணா we will be able to know what is the value of x. வேற நான் காமிக்கிறேன் எப்படின்னு சொல்லிட்டு. ஏன்னா இது ஒரு எக்ஸாக்ட் குவாட்ரேட்டிக் கிடையாது, குவாட்ரேட்டிக் ஈக்குவேஷன் தான், பட் here we will not have the constant term. எங்கன்னா அந்த கான்ஸ்டன்ட் டேர்ம் கிடையாது, வெறும் இந்த எக்ஸ் ஸ்கொயர் அண்ட் என்னது எக்ஸ் ஸ்கொயர் டேர்ம் இருக்கு, அதுக்கப்புறம் எக்ஸ் டேர்ம். இங்க பாருங்க, we will cancel 1x on both sides. அப்படி இது அந்த பக்கம் எடுத்துட்டு போங்க. so what you will have, mg sin theta minus mu mg cos theta is equal to half kx. okay, so பாருங்க, what is it? 2 இந்த பக்கம் போனா it will go to the numerator, k will come to the denominator. 2 times of mg sin theta minus mu mg cos theta whole divided by k. அதுதான் x ஓட வேல்யூ. x ஓட வேல்யூ என்னது? 2 times of mg sin theta minus mu mg cos theta by k. Okay va? So this is the approach to solve the problems where we are having the friction. So if they are giving an actual values means பாருங்க இந்த क्वेश्चनல நமக்கு m ஓட வேல்யூ இருந்துன்னு வெச்சுக்கோங்க. அந்த மாதிரி theta value is there and we have the mu, we have the k, then we can solve for what is the actual value of elongation that can be there. Okay va? So this is about the spring on the inclined plane type of problems. So look at this one. This is another standard question. Okay va? So paranga, in this figure, right, there is a block A released from rest. From that position, let us call it as what? Point 1 and when the spring is in the natural length, spring is in the natural length. The block A release it is in the natural length. Okay va? So paranga, because of the weight acting on that block, the block will start going down. So when the block is going down, right, the spring will keep getting elongated. When the block is going down, spring will get elongated. Okay. For the block B of mass m, block B or mass, what is it? M. For the block B of mass m to leave contact with the ground. Leave contact with the ground and so now what is it? Paranga, leave contact with the ground means the spring force acting on that block B should overcome its weight. The block B of mass m leaving the contact with the ground and so now spring force, because spring is getting elongated means spring will start exerting the spring force, right? The spring force acting on the block the block B spring force upwards dana. So the upward spring force should overcome the weight of the block B. The block B will lose the contact and so now when the upward force is more than the weight, right, it will start going up. Okay, so paranga question statement, for the block B of mass m to leave the contact with the ground at some stage, what should be the minimum mass of block A? The block A oda mass minimum value evlo irukano, adha question. So eppadi idu nama solve pandradha paranga. How we can solve this? Let us say the block A oda mass evlo solli namakku theriyadu. Block A oda mass, let's say it is some m dash nu vechukonga. Block A oda mass evlo m dash. Okay va? So inga we look at this as the point 1. This is the point 1. Okay va? When the block A is going down, block A kela போகும்போது என்ன ஆகும் பாருங்க, it is initially at rest. So when it is going down, அதோட gravitational potential energy will start decreasing. என்ன கீழ வருது. Okay, but what is happening? Spring is getting elongated. What is happening? Spring is getting elongated. இங்க பாருங்க, when it comes to point 2, when it is coming to point 2 where the block is coming down by a value x, the block is coming down by a value of x. Okay va? The decrease in gravitational potential energy evla, the decrease in gravitational potential energy evla mg into x dana. Enna மேல இருந்து it is coming down by a value x. So decrease in gravitational potential energy evla mgx. இந்த பக்கம் பாருங்க, increase in இது m கிடையாது m dash, ஏன்னா we are talking about the block A. Okay va? Increase in spring potential energy எவ்வளவு பாருங்க, half kx square. Increase in spring potential energy எவ்வளவு, half kx square. Okay, so இப்ப என்ன தெரியுமா, when we are looking at the just leaving the surface, the spring force, right, should be more than or equal to mg. And a spring force should overcome the weight of the block B, right? Means what? Spring force acting on the block B should be more than or equal to its weight. Okay. So when we are looking at the decrease in potential energy of the block A relating to the increase in the spring potential energy, the relation between them will be what? Another m dash into gx is equal to half kx square. M dash into gx is equal to what? Half kx square. Whatever the assumption is what? The work done by other forces we are not, because we are not considering the friction நம்ம கன்சிடர் பண்ண போறது கிடையாது. அந்த மாதிரி we are also not considering the gravitational force, and tension is an internal force. Tension பாருங்க, இந்த பக்கம் ஆக்ட் ஆகும், இந்த பக்கம் ஆக்ட் ஆகும். Tension will be acting on both sides. Okay, tension will be acting on the block A side as well as the spring side. அதனால tension will not be considered. So we are taking the block and the spring together. Okay va? So the increase in the spring potential energy we are equating to what? The decrease in the gravitational potential energy of the block A. அப்படி பண்ணா அதுல இருந்து நமக்கு என்ன வரும்? X value வரும். பாருங்க, what is the X value? ஒரு X நம்ம கேன்சல் பண்ணா what is the X value? 2m dash g by k. அதுதான் X ஓட value. What is the X value from here? 2m dash g by k. Okay va? So இப்ப பாருங்க, with this value, if we want to, is the X value. So the corresponding spring force, இதுல இருந்து வர spring force எவ்வளவு? K into X தானா? So what is it? K into அப்படியே நம்ம மல்டிப்ளை பண்ணணும், 2m dash g by k. So corresponding spring force எவ்வளவு வருது? 2m dash g வருது. Okay, so பாருங்க, what is the condition we are looking for? Spring force acting on that block B should be more than the weight of the block B. அப்படிதானா? So which means what? 2m dash g should be more than or equal to mg. இப்போ பாருங்க, g cancel ஆயிடும். So what is it? m dash should be more than or equal to m by 2. So அவங்க என்ன கேக்குறாங்க? The minimum mass of the block A. So block A ஓட mass, right, m dash should be more than or equal to m by 2. அப்படி சொன்னா what it means? The minimum value is what? M by 2. So block A oda mass, if it is having a value of m by 2 or more, then as it is going down, right, at some stage it can lift the block B. It can lift the block B from the surface. Okay va? So this is about another, it's a very standard question. So over side you will have the blocking on a side, you will have a spring connected to another block. So what is the condition we are looking for? The minimum mass of A. This is a standard result மாதிரி தான். ஏன்னா if they are giving a question எடுத்துக்கோங்க, they can give question like this. In the bucket they will be putting a weight mass of 6 kg. They will ask us what is the minimum mass of the block A, so that the 6 kg will go up. அப்படி கேட்டா what is the answer going to be? M by 2 means what? 6 by 2, which is 3 kg. And the bucket block A minimum mass should be what? 3 kg, so that the 6 kg will be lifted up at some point. Okay va? So எப்படி இத நம்ம approach பண்றது? As the block A is going down, its potential energy will be decreasing. That is resulting in what? Increase in the spring oda potential energy. So ரெண்டுத்தையும் நம்ம ஈக்குவேட் பண்ணா அதுல இருந்து we are getting what is the elongation x value. We are getting what is the elongation x value. So அதுல இருந்து whenever looking at the spring force, right, spring force oda formula என்ன? Kx தானா? So we are getting what is the spring force. Condition is what? If the block B should leave the surface, means spring force should be more than the weight of the block B தானா? So அந்த condition நம்ம apply பண்ணா என்ன வருது? We are getting what is the minimum value of m dash. Okay va? So அடுத்தது என்ன? We are looking at a very simple concept of the spring combination, and I think we might have covered this already in the Newton's laws of motion, but again we are covering here because this will be not only useful for the work energy theorem concept, but it will be useful in the discussion about the oscillation chapter also. Combination of springs and sonna, generally we look at two types of combinations. Or series combination and parallel combination. Series combination enna theriyuma, if you are having one spring, okay, apdiye the other spring is connected, so the common point varum, there will be common point. Inga we are connecting two springs, other constants k1 and k2 nu vechukonga. We can have three springs also. Adu eppadi, inga one spring nama connect pannalam. So this is, you have a common point. So series connection enna theriyuma, the springs will be connected with a common point. Okay, so adanal enna inga parunga, the spring 1 will create a force. If the spring system is elongated or compressed, right, spring 1 will create a force. And madri indha pakka the force created by spring 2 varum. The common point should be static, right? So once you elongate it or once you compress means the common point should be static, which means what? There must be a force balance. And the common point should be having a force balance. So if the force inside the spring 1 is F1 vechukonga, force inside the spring 2 is F2, there should be a force balance, means what? F1 oda value should be equal to F2. Inge appadida, force in the spring 2 evada F2, force in spring 3 is what? F3. So common point should have a force balance. The common point will keep getting elongated, or because if the force is not balanced means it will keep moving, right? So whenever we have springs in series, the common point should have the force balance. Force balance in sonna, one side force value should be equal to the force on the other side. One side you will have a force due to one spring, other side you will have a force due to other spring, which means when you are having a series combination, the force in each spring is the connection between them. Force in each spring will be same. Why? Because the common point should have a force balance. And then the common point should be having a force balance. Okay, va? So when you're having a series combination of springs, the spring or a series combination, and what is the thing about the series combination of the springs? The common point should have the force balance. Abadi sonna what it means? The force in each and every spring, let us say there are 5 springs in series vechukonga, the force in spring 1 will be equal to force in spring 2 apdi varum. Okay va? So now we are going to look at the concept of equivalent spring constant. Another equivalent spring constant. Equivalent spring constant and sonna theriyuma. Let's say for example, நம்ம கிட்ட இந்த காம்பினேஷன் ஆஃப் ஸ்ப்ரிங்ஸ் இருக்கா, ஓவரால நம்ம எலாங்கேட் பண்றோம் x, இந்த காம்பினேஷன் எடுத்துட்டு நீங்க ஒரு x எலாங்கேட் பண்ண வச்சுக்கோங்க. There will be some elongation in the spring 1, some elongation in the spring 2, some elongation in the spring 3. அப்படிதானா? So x1 plus x2 plus x3, அதோட வேல்யூ என்ன? total elongation. x1 plus x2 plus x3 எவ்வளவு? x. Okay, so இப்போ கான்செப்ட் என்னன்னா, you replace all these the 3 springs, இந்த 3 springs ஒரே spring வச்சு நம்ம replace பண்ணா with a spring constant k equivalent ன்னு சொல்லலாம். இதுதான் நம்மளோட equivalent spring of the combination. என்னது? அந்த 3 springs நம்ம replace பண்ண போறோம். எதை வச்சு? ஒரே single spring வச்சு. This spring will produce the same force. This spring will produce the same force as the combination. என்ன நான் replace பண்ணனும்னு சொன்னா what is it? இதுக்கு முன்னாடி இருக்க combination, whatever the force the combination is giving, right, the equivalent spring should also give the same force. Equivalent spring should also give the same force. இங்க பாருங்க, what is the force that the equivalent spring will give? K equivalent into the elongation x. ஏன்னா equivalent spring ஓட elongation எவ்வளவு இருக்கும்? X. இப்போ பாருங்க, தனித்தனியா when you look at these three springs, right, because they are in series combination, each of them will have the same force. Each of them will have the same force. That will be the force in our equivalent spring also. That is the force in our equivalent spring also. இங்க பாருங்க, எப்படி relation வரும்? F is equal to what? K1 into x1. அந்த மாதிரி இங்க என்ன வரும்? F is equal to K2 into x2. அந்த மாதிரி இங்க என்ன வரும்? F is equal to K3 into x3. இப்போ என்னன்னா, we will try to look at the relation between, எப்படி, how do we find out the equivalent spring constant of the combination? நம்ம கிட்ட ஒரே ஒரு ரிலேஷன் இருக்கு. What is it? x1 plus x2 plus x3 is equal to x. பாருங்க, இங்க இருந்து x1 எவ்வளவு வரும்? F by k1. x2 F by k2. x3 எவ்வளவு? மூணுத்தையும் நீங்க ஆட் பண்ணுங்க. F by k1 plus F by k2 plus F by k3 is equal to, இங்க பாருங்க, from the equivalent spring அங்கல இருந்து நம்ம x ஓட வேல்யூ எடுக்கலாம். What is x value? F by k equivalent. அவ்வளவுதானா? ரெண்டு பக்கம் நம்ம f கேன்சல் பண்ணலாம். f கேன்சல் பண்ண என்ன ஆகும் பாருங்க, 1 by k1 plus 1 by k2 plus 1 by k3 is equal to 1 by k equivalent. இப்படி தான் வரும். So if you are having a series combination of springs வெச்சுக்கோங்க, then for the series combination of springs, right, we want to replace all of them by one single spring and சொன்னா, what is it? The equivalent spring constant எவ்வளவு? 1 by k equivalent is equal to what? 1 by k1 plus 1 by k2 plus 1 by k3. அப்படி வரும். Okay. So இதோட ஸ்பெஷல் அனாலிசிஸ் என்னன்னா, when you are dividing a spring into parts, இங்க பாருங்க, நம்ம கிட்ட ஆல்ரெடி ஒரு ஸ்ப்ரிங் இருக்கா with a constant k. அதை நம்ம ரெண்டு பார்ட்ஸா டிவைட் பண்ண போறோம். Okay. So we are dividing it into what? Two equal parts னு வெச்சுக்கோங்க. We are dividing it into how many parts? Two equal parts. Okay. So let us say each of them எவ்வளவு? k dash னு வெச்சுக்கோங்க. So it is like what? These two are in series to form the original spring. அப்படிதானா? See, இப்ப நம்ம original spring cut பண்ணிட்டு we are bringing these two parts. இது நம்ம இன்னொரு விதமா எப்படி பார்க்கலாம்? The two parts are joined in series to bring the original spring. அப்படிதானா? The two parts are joined in series to bring the original spring. Two parts are joined in series and சொன்னா, what is the relation? 1 by k dash plus 1 by k dash is equal to what? 1 by equivalent is what? K only, no? இங்க பாருங்க, 2 by k dash is equal to 1 by k. இதுல என்ன வரும்? K dash is equal to 2k. Interesting தானா? ஏன்னா when you cut the spring into two equal parts, each part oda spring constant is what? Increasing. Each ஒரு part oda spring constant is what? Increasing. How much it is becoming? It is becoming what? 2k. So when a spring is having a smaller length, என்ன ஆகும்? The stiffness constant will be increasing. நீங்க இந்த practically நீங்க observe பண்ணலாம். If you are having a small spring வெச்சுக்கோங்க, அதை நம்ம compress பண்ணனும்னா இல்லனா expand பண்ணனும்னா it will be too difficult. If you are having a longer spring, right, compressing it or expanding it will be easier. Okay va? So this is how the dividing of the spring. இப்போ என்ன தெரியுமா? If you are dividing, இது ஒரு நம்ம generalize பண்ணலாம். இப்போ 3 parts நம்ம divide பண்ணா என்ன ஆகும்? Each of the part will get 3k. அப்படிதானா? If you are dividing the spring into n number of equal parts, if you are dividing the spring into what? N number of equal parts, அப்படி நம்ம divide பண்ணா, what is the general result? If a spring is divided into n number of equal parts, அப்படி நம்ம divide பண்ணா, each part oda spring constant எவ்வளவு வரும்? If a spring, original spring oda constant என்ன? K. Each of the parts will have a spring constant of n times of k. இது ஒரு standard result. இப்போ நம்ம பார்த்தது என்ன? நம்ம ரெண்டா டிவைட் பண்ணா each of them is becoming what? 2k. You would divide this into three equal parts. அப்ப என்ன வரும்? Each of them will become 3k. you divide this into 10 equal parts. அப்போ ஒரு பார்ட்டோட spring constant எவ்வளோ? It will be what? 10k each. ஓகேவா? So this is about dividing the spring into equal parts. இன்னொன்று என்னன்னா, we can divide the spring into unequal parts also. அப்படி நம்ம டிவைட் பண்ணலாம். அப்படி டிவைட் பண்ண ஆகும் பார்க்கலாம். So if you are dividing a spring into unequal parts, unequal parts are the lengths will not be same. அப்ப என்ன தெரியுமா, we are going to use the relation between the length of the spring and spring constant. we are going to use the relation between length of the spring and the spring constant. இப்ப பாருங்க, we are having a spring of constant k and length L ன்னு வெச்சுக்கோங்க. This is our original spring. இதான் நம்மளோட original spring. ஓகேவா? இப்போ என்ன, we are going to divide this into different parts. இதோட length L1 வெச்சுக்கோங்க, இது L2, இது L3. each of them k1, k2, k3. இப்போ நமக்கு என்ன வேணும்னா, how do we know what is the value of k1, what is the value of k2, what is the value of k3? okay, so இப்போ பாருங்க, for a spring, right, இதுக்கு முன்னாடி நம்ம டிஸ்கஸ் பண்ண மாதிரி, what is it? if the length is more, the spring constant will be less. அது எப்படி தெரியுமா, the product of the spring constant into length will be a constant value for a spring which is made up of a particular material and area of cross section. அது ரெண்டு காமனா தான் இருக்கணும். அப்படி இருந்தா then you know what is the relation? The spring constant into length will be maintained as a constant value. means என்ன வரும் பாருங்க, k into L, k is the spring constant of the original spring into அதோட length is equal to what? part 1, what is the constant k1, அதோட length L1. part 2, part 3, பாருங்க, நம்ம k1 வேணுமா, k1 will be what? k1 will be what? k into capital L by L1. அந்த மாதிரி k2, k into capital L by L2. அப்படியே k3 வரும், k3 will be what? k into capital L by L3. so when you are dividing a spring into unequal parts, அங்க எப்படி, what is the relation we are going to use? relation between the spring constant and the length of the spring. அது எப்படி, for a spring that you are dividing into different parts, the constant of the spring multiplied by its length will be common. the எல்லா பார்ட்ஸ்க்கும் காமன் தான் இருக்கும். that will be equal to what? the constant of the original spring multiplied by its own length. okay, on the relation which nama we will try to find out what is the spring constants of each of these parts. இது ஒரு important result. ஏன்னா இதுக்கு முன்னாடி நமக்கு past year நீட்லயும் வந்தது, dividing the spring into unequal parts. ஓகேவா? other than that, we can have a parallel combination of springs. parallel என்ன தெரியுமா, so இப்படி, like we keep them in parallel, literally parallel connect பண்ண மாதிரி. பாருங்க, there is a spring k1 and then a spring k2. இந்த பக்கம் என்னது, we are having a spring k1, spring k2. இப்போ பாருங்க, what do we need to find? we need to find what is the effective spring constant. effective spring constant என்ன, இந்த ரெண்டுத்தையும் நம்ம ஒரே spring வச்சு replace பண்ணா, that is what we call as what? equivalent spring or the effective spring. இப்போ என்ன தெரியுமா, we will just look at a extension of the spring by a value x. the system is எப்படி, extended by a value x. அப்படி நம்ம extend பண்ணா பாருங்க, mass இங்க வரும். so spring 1 will be extended by value x. அந்த மாதிரி spring 2 எப்படி, that will also be extended. so பாருங்க, force in spring 1 எவ்வளோ, k1 into x. force in spring 2 எவ்வளோ, k2 into x. so total force will be what? f1 plus f2 தானா, ஏன்னா both force 1 will be acting on the block, force 2 also will be acting. so then இது k1x plus k2x. இங்க பாருங்க, when you replace the springs by a equivalent spring, அதையும் நம்ம அவ்வளவுதான் displace பண்ண போறோம். we are going to displace the mass by same value x. இப்போ பாருங்க, what will be the force here? k equivalent into x. ஆல்ரெடி நம்ம என்ன சொல்லிருக்கோம், whenever we are talking about a equivalent spring or a effective spring, right, whatever the force given by the individual springs of that combination, the total effect should be represented by the equivalent spring. அப்படிதானா? So இங்க பாருங்க, the combination of parallel springs, right, they are contributing how much total force? எவ்வளவு? k1x plus k2x. That should be contributed by the equivalent spring alone. அப்படிதானா? So ஏன்னா நம்ம அந்த combination ஒரே spring வச்சு நம்ம replace பண்ணோம்னு சொன்னா, what is it? The equivalent spring should provide the same amount of force. Same amount of force ன்னு சொன்னா, what is the force given by the equivalent spring? K equivalent in x, right? இங்க பாருங்க, x நம்ம cancel பண்ணலாம். What is it? k1 plus k2 is equal to k equivalent. இப்போ இந்த மாதிரி மூணு ஸ்ப்ரிங்ஸ் இருந்து வச்சுக்கோங்க, then we will get what? k1 plus k2 plus k3 is equal to k equivalent. அப்படிதான். If we are having 10 springs in parallel, அப்ப என்ன வரும்? k1 plus k2 plus k3 plus k4 அப்படியே up to k10 will be equal to what? K equivalent. Series என்ன? What is it? 1 by k1 plus 1 by k2 அப்படி is equal to 1 by k equivalent. Parallel means what? k1 plus k2 plus k3 is equal to k equivalent. இப்படி வரும். ஓகேவா? So இந்த ரெண்டு ரிலேஷன்ஸ் நமக்கு ஞாபகம் வச்சுக்கணும். This is what? The combination of springs in series and combination of springs in parallel. இங்க பாருங்க, இந்த solve இந்த problem முடிச்சிட்டு we'll wind up the session. A spring of constant k, a spring of constant k is divided into 3. எத்தனை parts? Is divided into 3 parts of ratio of length 1:2:3. என்னது? ஒரு ஸ்ப்ரிங் இருக்கு நம்ம கிட்ட of constant k. அந்த ஸ்ப்ரிங் நம்ம டிவைட் பண்ண போறோம். எப்படி? we are dividing into 3 parts. Lengths are different, unequal. இது என்னது? unequal breaking or dividing. Okay, this is having a length ratio தான் கொடுத்திருக்காங்க, 1:2:3 ratio. okay வா? What is the spring constant of each part? இப்போ என்ன சொல்லலாம்? k1 k2 k3 ன்னு சொல்லலாம். Remember, we have the formulas. What are those? The spring constant of the original spring into அதோட length L ன்னு வெச்சுக்கோங்க. Its length will be equal to what? k1 into the length of this series L1 ன்னு வெச்சுக்கோங்க. k2 into L2. That will be equal to k3 into L3. இதுதான் relation. இங்க என்னன்னா, they have not given us the L value. அந்த மாதிரி they have also not given us the L1 or L2 or L3. இப்போ என்ன தெரியுமா? We will have to get the relation by using this. Say L is the original spring oda length ன்னு வெச்சுக்கோங்க. Then what is the ratio it is divided? 1:2:3. So அப்ப என்ன தெரியுமா? L1 will be, so total sum of the ratios எவ்வளவு பாருங்க, 1 plus 2 plus 3 எவ்வளவு? 6 தானா? So L1 will be 1/6 into L. L எவ்வளவு பாருங்க? 2/6 into L. அந்த மாதிரி L3 எவ்வளவு பாருங்க? 3/6 into L. எப்படி வருது? The ratio is what? 1:2:3, right? Total ratio sum எவ்வளவு? 1 plus 2 plus 3 6 means L1 will be what? 1/6 into L. அந்த மாதிரி L2 will be what? 2/6 into L. L3 will be what? 3/6 into L. இப்படி தான் நம்ம டிவைட் பண்ண போறோம். Whenever they are giving us the ratio means, how do we divide the quantity? The particular ratio value divided by sum of these ratios into total value. Okay, so இது L1 relation to L, அந்த மாதிரி L2 ஓட relation to L, அந்த மாதிரி L3 ஓட relation to L. இங்க பாருங்க, K1 வேணுமா? What is K1? அவ்வளவுதான், முடிஞ்சது. So K1 is what? K into capital L. What is K1? K into capital L divided by L1. அவ்வளவுதான். பாருங்க, what is K1? அங்கல இருந்து K1 எவ்வளவு? K into capital L by L1. So L1 means what? L1 எவ்வளவு? 1/6 into L. So 6 மேல போய்டும், 6k. K2 பாருங்க, K into L by L2. L2 என்னது? 2/6 into L means 1/3L. 3 மேலே போயிடும் 3k. K3 பாருங்க k into L by L3 வரும். L3 என்னது 3/6. 3/6 சொன்னா 1/2. LL cancel ஆகிடும், 2 மேலே போயிடும். So the spring constant of each of the parts is what? 6k is the part 1. அதுக்கப்புறம் 3k is for the part 2. அதுக்கப்புறம் 2k is for the part 3. So this is how we will solve the problems where we need to find the spring constant when you divide a original spring into unequal parts. Unequal parts நம்ம divide பண்ணா இப்படி தான் நம்ம approach பண்ணணும். ஓகேவா? So இதோட we will try to wind up the applications of the work energy theorem with regard to the springs. Next session we will start with the vertical circular motion and how we will apply the work energy theorem in the vertical circular motion. Okay, so adoda the applications of the work energy theorem will be completed, and then we will go into the momentum discussion part, collision, explosion. Okay, so we will see in the next class.